I was literally just editing my video on o4-mini and OpenAI's new Coding CLI tool when the news broke that OpenAI is in talks to buy Windsurf for around $3 billion. That is absolutely insane. With the resources and engineers they could put behind this, they could begin to really rival Cursor and GitHub Copilot. Anyways, on with the original video. It's been a busy few weeks for OpenAI, but this one feels significant. We finally have the full O3 model, as well as o4-mini, and things are getting scary good.
I got one more thing.
They even released their own coding tool to rival Claude Code, which we'll be trying out. So here in ChatGPT, we have access to the models already. First, we have the new O3 model, which is the full O3 version. It's that state-of-the-art model which wins the benchmarks in math, coding, science, visual perception, and much more. Then we have o4-mini and o4-mini High. Now this is a smaller model which is optimized for fast, cost-efficient reasoning, and the numbers are super impressive. But let's try out O3 first, as I want to show you a really impressive demo. If I give O3 a screenshot of a poster on Proton isovector scalar charge, something one of the OpenAI engineers actually worked on, this is one of his posters, I can say here's a screenshot, I didn't actually get the final value, please go ahead and search for any recent research findings that may have updated the estimates and see how they compare to the poster. If I hit enter on this though, what I wanted to show you is what this is doing. So this is an image that I've uploaded here. So first it's going to do the reasoning step. And then after a while of reasoning there, it's actually trying to run OCR on this poster to try and work out what the text is actually saying. It's using some of the tools that it has access to. And then this step I find really impressive. It's analyzing the image here, and then it wants to zoom in on the image to find specific bits. So it's cropping the image, zooming in and trying to read specific points to make sure that in its context, it only has the specific information that it needs at that time. You could even see there at the end that it said the graph was too small and it needed to zoom in even more. And it's doing this once more. It's looking at different parts of the image now, zooming in on the plot graphs and trying to find the answer for me. So it's really going through many steps to try and work out what I wanted. And there we go again, you can see it zoomed in on that bottom part to read the conclusion. It's reviewing it, it's analyzing another bit of the plot point, and it's just trying to work out the answer. It's so cool how it's just really analyzing and breaking down this poster to get me the answer that I wanted, all from a single screenshot. Once it's analyzed everything that it wanted from that poster, it zoomed in a few times, it ran OCR on different points that it cropped to. You can see that it's looking for recent research. Now it's going off and searching the web for me here, looking up lattice QCD isovector scalar charge things. And there we go, after 7 minutes here, we have an answer. Now I imagine this took a lot longer than it did in that demo, which only took around a minute, because they're probably throttling the O3 at the moment, it literally just came out. But you can see in the answer it's given us here that it says what your poster already tells us, it gives us some diagrams, it goes through everything, shows us physical review, and it just gives us some sources down at the bottom as well. But what I really wanted to show you about all of that was the steps that it took in breaking down the image, running OCR over all of that image there, then cropping it into smaller portions, reading that, trying to read the plot diagram, recreating its own. It just uses so many tools and it feels really smooth. That is the magic of these models. They can use all of the tools in ChatGPT, so they can search the web, analyze files, generate images, and everything else. These are all trained to use these tools really well as well, often thinking for around a minute and cooling tools before giving you a response. It really feels like they're doing deep research without doing deep research. Now, since there's a good chance that you're a developer watching this, let's try it out with the bouncing ball hexagon program. We'll start out on O3 here, and as you can see, after thinking for 49 seconds, it's given me a program that I'm now going to try and run. Loading that up then, it seems to have worked perfectly first try, the physics seem alright here to me, and I didn't have any errors actually running the script, it did it all in that one shot. I'll give that same prompt here to ChatGPT o4-mini High. o4-mini High seemingly nailing that prompt there, and you can see this is working in a similar way, just with that red ball now, and you can see the physics seem to work, it's not falling out of the hexagon or anything like that. So finally, as a comparison, let's test this against 3.7 Sonnet and the reasoning version. And as you can see, 3.7 Sonnet nails this as well, so it seems this rudimentary benchmark we do with this hexagon is running out of room, and the models have caught up with it. But don't worry, we'll be talking about the real benchmarks in a bit. Now let's talk about that coding tool that I mentioned at the start. It's called Codex CLI, and it's a lightweight coding agent that you can run from the terminal. It's designed to maximize the reasoning capabilities of models like O3 and o4-mini, with upcoming support for additional API models as well, like GPT 4.1. Even cooler though is it's completely open source and you can find Codex on GitHub. Once you get this installed with npm, all you need to do is type in Codex and you'll be greeted with a screen like this. As you can see, the model is o4-mini here. The approval mode is suggest, which I assume it's going to ask me things and I'll have to confirm yes on them. And you see I'm actually inside of the React codebase at the moment, which is quite a large codebase, so I want to see how it deals with that. Now you might notice up here that I actually ran this from build on my machine. I cloned the files and ran it. I actually ran into an issue and had to go into the code and fix it myself. So a total win for open source there. But let's actually try this out. And I just want to see first if it can explain the code base to me. So I've asked it to explain the structure of this code base here and its thinking, and it seems to be just going through the directories and actually listing what files are in there at the moment. And after about a minute here, you can see that we have the final output just explaining the React code base structure. It just went over the top level of the files and had a look at them. And you can see it did some of those tool calls, running ls to list out what files were in each directory. Let's put it to the test with some actual coding though. Here you can see I've got an index.html, which is just an impossible Pong game, where we can choose the mode to be AI versus AI or player versus AI. And we also have the difficulty of basic, gets fast, and insane. But I want to add a few more features to this. You can see the prompt that I'll be using here. I want to add an overlaid style pop-up to the start of the game on first load. Between each point, show a 3-second countdown. After each game that the AI wins, display a lighthearted insult, and so on. So let me paste that into Codex CLI, and you can see it's going off and thinking. It's running commands to get specific lines of code in its context. And there we go, it is finally done. Now this did actually take around 10 minutes. I don't know if there's some rate limiting going on, but you can see it applied the final patch here and we can see the diff view, but did this code actually work? Well, loading up the index.html, we already have a difficulty selector, so I'll go even more insane. Hit start game, and it doesn't seem that that's faster, so maybe I need to tell it to re-implement that. Okay, there we go, we lost a point there, so it's added in the countdown as well. I'm gonna go ahead and lose a game on purpose here, definitely on purpose. And after the AI wins here, you can see we get a pop-up that says AI wins, and then the AI told me that its grandma plays better. So you've seen it all in action, but let's talk about the benchmarks. I'll start out with coding. On SWE Bench Verified, o3 scored 69.1%, while o4-mini scored 68.1%, so I cannot wait for that full release of o4. For reference, 3.7 Sonnet actually scores 62.3% without custom scaffolding. On Ada Polyglot, Gemini 2.5 Pro was the previous winner with 74% whole and 68.6% diff. Now o3 High actually scores 81.3% and 79.6% on diff, with Mini following up closely with 68.9% and 68.2% diff, so o3 really is the coding king. Now, in terms of other benchmarks, o4-mini is actually near 100% on AIME, a math benchmark, which is insane. o3 scores 98.4% as well, and Gemini 2.5 Pro was the previous winner with 92% without tools. On Humanities Last Exam, o3 with tools scores 24.9%, so it's nearing deep research levels, but in a fraction of the time it takes. Again, Gemini 2.5 Pro was the previous winner here with 18.8%, so this is quite a significant leap. Finally, what about your wallet? How much is this going to sting? As if you remember, o1 Pro was their priciest model, coming in at $600 for 1 million output tokens and $150 for input. Ouch. Well, luckily o3 is a lot more reasonable, costing $10 for 1 million input and $40 for 1 million output. It's still pricey, but not as bad. o4-mini though is only $1.10 for 1 million input and $4.40 for output. One more thing I forgot to mention is don't worry, it can still giblify your images. Let me know what you think in the comments down below. While you're there, subscribe, and as always, see you in the next one.